we say that what is intelligent, right? Intelligent is used to describe a combination of smart devices. This is very important. Combination of smart devices and another systems. Not only smart devices, but with other systems. So many components, if added together, that become intelligent building. Right? Other components means what? HVAC system, security system, fire alarm system, cooling system, different types of system added together, that become a intelligent system. And it is clear that smart is the part of that. With supervisory software enabling coordination and collaboration between the smart atoms. An intelligent building requires real-time information, right? We understand this. It required real-time information, and from where we get? We get from that embedded advanced sensors about its occupant, so that it can continually adapt and respond. So continuous adaptation, and based on adaptation, the changing of the parameters value is required. You may know one concept of adaptive controllers. Adaptive controllers are controllers, they work on real-time data. What is the real-time conditions? Whether any disturbance change the output. That based on disturbance, adaptive controller modifies itself, and based on that they respond. So that the control is very accurate and robust. True intelligence implies the ability to automatically adjust operating parameters. What I said in earlier point, adaptation, this is the explain over here, automatically adjust operating points, parameter. There should not be any involvement of human being to modify the things, right? They have the ability to automatically adjust operating parameters interactively between smart atoms to optimize building functionality. Optimization plays very important role. The whole purpose is optimization. The optimization can benefits in following points. What are their benefits? Energy saving, occupant comfort, safety, and security. Or we can say that totally we get operational productivity. If such type of things are implemented in any building, that may be the mall, that may be any big building, or that may be any industry building, if such type of things are there, then and then we can say that it is an intelligent building. But at the core, an intelligent building is greater than the sum of its smart part. Okay, so we can see that it is not just the smart parts, there is more than that. So as I asked at the beginning, can you define intelligent building? This is the Intelligent Building Institute, IBI, located in United States, which state that an intelligent building provides a high efficient, comfortable, and convenient environment by satisfying 4 fundamental demands. These 4 fundamental demands are very important. That is structural type of things, system type of things, the services, and the management, and optimizing their interrelationship. So they have to be interrelated to each other. When this four base structure will be fulfilled, the IBI says that we call that as a intelligent building. The European Intelligent Building Group, EIBG, that is located in United Kingdom, what they defines? They defines an intelligent building as a building created to give its users the most efficient environment. At the same time, the building utilizes and manages resources efficiently and minimizes the life cost of hardware and facilities. Few things are added in this definition because the things are get updated day by day. According to this EIBG, they added some of the things in this their definition. Right? They focus on efficient environment. They focus on the resource management, efficient resource management, and they also focus on the life cost should be minimized in terms of hardware and the facilities required in that particular building. Some of the definitions from the Japanese Intelligent Building Institute, JIBI, what they say, their definition is mainly based on service-based sector. Service, how we provide service. An intelligent building is a building with the service functions of what kind of service? Communication service, office automation service, and building automation service, and it's convenient for the intelligent activities. So their focus is mainly on the service type of functions from the Japanese Institute of Building Automation, JIBI. Finally, I can say that there is one more group of scientists, that is Chinese Intelligent Building Design Standards. They work on this particular design standards. What this is, we state that intelligent buildings must provide building automation. You can see that the sum of the sentences from the Chinese IB design standards is very similar to Japanese. Building automation solutions, office automation solutions, communication network part they added, network systems, and optimal composition integrates the structure, system, service, and management. If all these things are together, then there should be their optimization with the structures, systems, service, and management, providing the users, providing the building with high efficiency. They added this word, high efficiency, in terms of energy saving, maintenance, etc. Comfort is also added, convenience and safety to the users. This word is very important from the Chinese definition, safety to the user. How to make building intelligent in reality? But question is that how to make buildings intelligence in reality? We discussed this point now. It is obvious that intelligent buildings cannot exist without involving technology system. It is clear, right? Now from the earlier discussion, it is clear that intelligent building cannot exist without technology and their systems. But having those technology systems is not enough, but that is also not enough. To make a building an intelligent one, furthermore, the technology system should be correctly configured and properly integrated with each other. Yes, we can have technology available, everything is available, but what important thing is that they have to be configured to each other very correctly. Proper integration of each and every component that is used in building automation system need to be configured with each other, so that then it is possible to make intelligent building in reality. The system functions should be appropriately customized to meet user requirement. So what actually user requires, customer requires, based on that the features required to be customized. That is important part. And to provide the expected performance of intelligent building. Performance monitoring is also important. It is not that we can use any kind of instrument in particular building that may be inefficient, not performing well. So performance analysis of each and every component used in building automation system is required. Their analysis is required. Finally, what we say? Finally, the technology systems, including their integration and interoperation, should be properly commissioned and maintained. So finally, maintenance is also very important. Everything is, yes, properly commissioned. Yes, now the building is intelligent building, but after that, the maintenance of each and everything is properly commissioned. That ensures that the functions are properly going on in any building. Beside the system, hardware and software, yes, we now understand that there are many software part also involved in any intelligent building, or we can say that IoT part, and many hardwares are also there. The application software is also important. The application software, including that for the facility automation and control, means the softwares that we are using in any control system, that must be upgraded, that must be customized, that must be commissioned. Right now, the softwares, what softwares we are using, what we are using SCADA system, DCS system, or we are using any conventional system, we have to be focused on that also. So application software means facility of automation and control, optimization and management should be customized and commissioned appropriately. A building may have technology systems, right? But if they are not working correctly, again we say the same thing. Yes, everything is there, but if they are not working correctly, it will not make the building intelligent in reality. Instead, the technology system may create headache for the operators and users. Okay, so they have to be worked very well, correctly, rapidly. They must be adaptive. They have to analyze the changes. All such things, they have to be properly maintained, properly commissioned, upgraded things. Everything is required in any intelligent building. To make a building intelligent in reality, what we say, which are the different things involved to contribute, because it is not the only role and responsibility of instrumentation and electrical people. Intelligent buildings are interdisciplinary. There is a structure part also. So civil engineering is also involved, mechanical engineering is also involved, instrumentation, electrical, as well as architecture's part is also very important. IBs are interdisciplinary and involve multi-industrial system engineering. It is clear over here. They require the right combination of architecture, structure, environment. So what are the different effects in environment? That is also very important. Building services, information technology, automation, and facility management. All such type of pupils need to be required in making any building into intelligent building. In addition, intelligent buildings are also strongly related to economic and cultural aspect, right? It is not that we can spend any cost and yes, it is okay. No. We have to be also strongly related whether it is feasible, it is economical, and can that building is based on the cultural aspect. The cultural aspect means don't religion aspect. The different cultural aspect means religion, in which area, which place this building is particularly we are developing, means it is nothing but the high level of user satisfaction. You don't take direct meaning of cultural aspect. Okay, it is a broad meaning. Its meaning is that we have to ensure that the high level of user satisfaction is there. So in that, cultural things are considered and economic things are considered. So what is intelligent architecture? Okay, so intelligent architecture concept now we will clarify. Intelligent architecture refers to the built forms whose integrated systems are capable of anticipating and responding to phenomena. Anticipating and responding to phenomena. That word is highlighted, whether internal or external, that affects the performance of building and its occupant. Means we have to take care that the things may be internal or externals, but that must be capable of anticipating and responding to the different types of phenomena. Intelligent architecture relate to the three distinct areas of concerns. Which are that three distinct areas? Based on that, we have to develop the architecture of intelligent building. The first area of the concern is intelligent design. The design part should be intelligent one. Second main focus on architecture is appropriate use of intelligent technology. Appropriate. Then third part is intelligent use and maintenance of the building. If these three things are fulfilled, we can say that the intelligent architecture is perfect one. So what is expectation in intelligent design? The first part, The building design respond to humanistic cultural issues. The things are adopted such that the building design responds that, you know, must be the responses for the humanistic and cultural issues. It exhibits simultaneous concern for economic, political, and global issues. These things are also need to be incorporated in design aspect of the building. This design aspect is mainly concerned with the civil engineering point of view and architecture engineering point of view. It produces an artificial enclosure which exists in harmony with the nature. Existing in harmony with nature includes responding to the physical laws of nature and the proper use of natural resources. You know very well that different things are required to construct a building. So you have to also take care that there should not be any effect on the nature because of such constructions, and their effect should not be there on the environment. So to fulfill all the physical laws of nature, and we have to use the natural means. Is it possible to have the place such window such that there should be natural air come inside? There is a natural flow of air through the building, so that automatically the natural resources are used and the burden will be less on the energy kind of things. There will be less effort required for the air conditioning, right now. So all such things are very carefully required to think on this particular design aspect, so that naturally we get the things, more natural things we get in the building. How the building should be cool with the natural things. Yes, all such thing. There should be proper light. If the windows are placed at proper places, there should not be any requirement of light during the day. Right? So all these things are required to be considered in this. So how to use appropriate use of intelligent technology? Large variety of smart materials and intelligent technologies often result in their use in appropriate situation. Now this is our part, instrumentation, electrical technology part. We have to use intelligent technologies, and intelligent technologies, smart things are made up of smart materials, so that efficiency will be high, consumption will be less, power requirement will be less, result in the use of. Otherwise what happen in appropriate situations, use in an appropriate situation. Integrating intelligent technology with an intelligent built form that respond to the inherent cultural preferences of the occupant is a central theme of intelligent architecture. Yes, the customer, the occupants, they are working over there, they live over there, they are using such building, they are doing their work there. Their cultural preferences, inherent cultural preferences are the center focus, and based on that, the design, the technology should be feasible or useful to the benefit of such occupants. As an example, in the areas where people place a high premium on operable windows for conservation of electricity, right? Operable windows. The most appropriate and efficient air conditioning strategy for a building may be use of thermal mass and nighttime free cooling instead of high-tech air conditioning system. It is not that we have to use high technology of air conditioning, so that may be highly consuming the energy, right? No, that should not be there. So we have to appropriately think the requirements based on the physical facilities, the environmental things, how we can incorporate to have the minimum burden on the existing technology. In other case, the use of carefully selected electric lighting and environmental control strategies may be more appropriate. You know very well CFL concept, LED concept, and old concept, right? So now older bulbs and that are not there now. After that there was a CFL bulbs, and nowadays there are LED bulbs. This is because of this. So we have to be carefully select the things, and based on that there is a required to develop the things in a particular building. Intelligent use and maintenance of building. This is the third aspect. And the last aspect, how to use and maintenance. Truly, intelligent architecture incorporates intelligent facility management processes. So, facility management also intelligent. That should be also intelligent, so that it is intelligent. For a design to be intelligent, it must take into consideration the life cycle of a building and its various system and components. Now this word comes. We have to very carefully consider the life cycle of building. Life cycle of building. We will clarify that later. Of a building and its various systems and components. So systems and components, it's a broad way, broad meaning, systems, various systems and components, various sensor, transmitters, converters, controllers, many components, many components, sprinklers, smoke detectors, CCTV, etc., etc. Although an intelligent building may be complex, it should be fundamentally simple to operate. Yes, it is complex, but other way, the operation should be simple and simple to understand to the occupants, be energy and resource efficient. Yes, it must be energy and resource efficient and easy to maintain also. It should be upgradable, modify and recycle. Not only that we place once so that we can't modify that to the higher versions. No. We have to modify. Upgradation, that is also must be before selecting that. We have to think on that. Can that particular component systems can be maintained easily? Can that be upgrade easily? Can we modify that easily? And can their recycle is also possible? Because the things are going waste, it has to be properly recycled. The materials and equipment that requires complex maintenance and unhealthy cleaning agents and building component that must be treated as a hazardous waste in the recycling process. Which are the hazardous components involved in that? Correct. So their discussion is mentioned over here. They may be complex. They may be difficult to maintain. Yes, complex maintenance. We can say that they may be hazardous. Then unhealthy cleaning agents may be present over there, that may be hazardous. And this type of things are, we can say that, hazardous waste in the recycling process. Example is also mentioned over here, the mercury in the light bulb, that is the hazardous part in that particular mercury lamps, will not be used in fully developed intelligent architecture. Such type of components should not be involved in the selection or the design process of the intelligent building, so that their recycling will be economical and environment friendly. That the upper level part is actually the, what we say, central unit. In central unit there is a workstation, there is a monitors, there are network trays, there are servers, web servers, and it is globally connected. The meaning of this internet-based things are nowadays is that it is not limited to that particular building. There may be n number of buildings are connected together through the internet facility. There is a broad meaning of that internet-based system, building automation system, intelligent building automation system. They are connected to different types of protocol, cables, networks, and through that, in every zone, through the router, the things are proceed further. May be connected to different lighting systems, access control systems, then heating, ventilation, and air conditioning systems, utility meterings, and many other services. CCTV is common in each and every place. So this is the general idea you will get for the typical floor, and maybe one middle one you will get idea for the high voltage switching room. In that there is one more router, that is connected to the again lighting system, HVAC system, as well as switching gears, utility metering, CCTV, diesel generators. Okay, all such components are also involved in a particular room also. And the common things are also mentioned in the right side. There are fire panels, there are excavation warning systems everywhere. There are, I think, smoke detectors, sprinklers. Right? There are burglar alarms. Then there are different types of local monitoring devices also over there. So in this we can now say that the upper part in that mostly the IT and IoT type of things are there, correct? IT, IoT type of things are there in the upper layer, and then communication is through IT networks. Different types of protocols are used, and yes, obviously in the middle one we can say that there is a much more efforts from the instrumentation and electrical point of view is required to use different sensors, their selections, you know, based on the different conditions we discussed earlier for the intelligent building. So selection is very important. It is not that we can use any kind of sensor and that. So we have to think very broadly, and we have to be fully focused on the requirements for the intelligent building. We focus on intelligent building requirement, and based on that we have to design the things. So these things are important as a instrumentation engineering point of view, and we can when we go more and more in the next discussions, again the more things will be get clarified. So what other component, what other things are also involved in this particular architecture? Some of the common things are mentioned over here. Lighting, major things, they are common in a particular architecture. Lighting, access control, and that CCTV. But yes, there are many and many other things are also there in a particular building. Right? The first evolution of intelligent building was from the 1980 to 85, integrated single function dedicated system. Right? They only have integration and communication between the automation system of different subsystems. Was impossible. There are different subsystems in any building, but their interconnection was not there, their integration was not there, right? Their commissioning was not there with each other. That was the scenario in 1980 to 1985. Then 1985 to 90, there were integrated multifunction systems. So in that, for some of the subsystem, there is an integration taken place. Mainly in security and access control, they were integrated to each other based on the access, how we can provide security. Then there is a more development in the year 1990 to 95. Buildings now become building level integrated systems. Now they become building level integrated system. So what happened in this? At this stage, a building automation system could be accessed remotely via telephone network, an old telephone network using modem, while the cellular phone for voice and data communication was introduced to the market. So based on the innovations, they can also be reflected in the intelligent building designs. Then in the year 1995 to 2002, computer integrated buildings are coming out. They can be remotely monitoring and controlling is possible. Right? With the help of internet was extensively spread over the world, and based on that, and we know that the main the source of innovation started in the United Kingdom, US, Japan, and China. So it is possible in this particular computer integrated buildings during that. So remotely we can monitor and control the buildings through the internet now, or different protocols, internet protocols. Now 2002 onwards, what now is going on till date? The integration and management at this level become possible due to the applications of advanced IT technology. Now we know that we say that this is IoT world, IT world, right? such as web services, XML, remote portfolio management, and help desk management, among other building. Means it is not only the building, single building. It is possible through internet and many other networks. It is possible to manage many things from the many buildings together. This is the recent, we can say that the enterprise network integrated systems, right, nowadays. And the same is shown in this figure also. The bottom is before 1980, then 1980 to 1985 things are mentioned. Then 1985 to 1990, what changes are there? Then 1990, 95 to 2002, and after 2002, how the things are going to be changed, that we discuss in this particular slide already. So now, what is life cycle of building? Yes, life cycle of building is based on three basic words. So design aspect of that building, what were the design, what was the design aspect, what was the design aspect, what were the design aspect, what was the commissioning scenario, and use of that. So can, if any problem occurs, we can use that particular things. Now we will discuss this in detail. Okay, building life cycle, BLC, building life cycle, refer to the view. So actually, this is the concept of analyzing a particular building. This you can understand in one sentence that if there is an existing building and there is a plan to modify that building to the intelligent building, right? So now there are some certain criteria we are placing. So based on that, can we have the, can it possible to incorporate building automation system in that particular building? Right? So we have to analyze, we have to view that building on some points. So BLC refer to the view of building over the course of its entire life. Means how much life that particular building has, but on what basis, that is required to be analyzed, find out from this particular life cycle concept. In other words, viewing it not just an operational building, but also taking into consideration the design. How the design, what was the design, the construction, how was that construction, how was their operation, how was the demolition, and the waste treatment is possible. Demolition is possible, but can possible to have the treatment, waste treatment, is it possible from that particular building? So these 4 or 5 things are very important in analyzing, viewing the life cycle of building. That is the design, construction, operation, demolition, and waste treatment. It is useful to use this view when attempting to improve an operational feature. If we want to improve that particular building to smart building, intelligent building, then we require to analyze that. Okay, operational feature of a building, that is related to how a building was designed. For example, overall energy conservation. Can that building was energy efficient? Yes, no. Means their analysis point of view, we are looking to the life cycle of building. In the vast majority of cases, but reality is what? In the vast majority of cases, there is a less than sufficient effort put into designing a building to be energy efficient. It's really sad. So because the focus was not there based on the energy efficient development, and hence large inefficiencies are incurred in the operational phase. So that becomes a very difficult thing for the development. What current research says? Current research is going in exploring methods of incorporating a whole life cycle view of building. So there are different technical, complete methods are available to find out the life cycle of a particular building, rather than just focusing on operational phase as in the current situation. In many methods that they find the life cycle of building, BLC, they only focus on the operational phase, but it is not that. there should be other more aspect that need to be focused. There must be design aspect, there may be construction aspect, so how long that particular building can be useful. Otherwise, how we can utilize this particular cost amount of investment to make it smart? It's very difficult. Demolition, after demolition, can the waste treatment is possible? So this is life cycle.